So we have derived the expression V is equal to 1 upon 4 pi epsilon naught Q upon R. This formula was derived by finding the work done per unit charge. So we get the formula for V as W upon Q naught is equal to 1 upon 4 pi epsilon naught Q by R. Now next one is potential difference, PD or potential difference. Let this be a plus Q charge. We have to move a charge from point A to B. Let this be moved from A to B. Then we have to find out the potential difference. Potential difference, from the word you can understand, it is the difference of potential between the 2 points A and B. So in that case, we can find VA minus VB. VA minus VB is equal to potential difference. Now here you can see that VA is away from the plus Q charge and VB is closer to the plus Q charge. So in that case, if we are moving the charge from A to B, then we find out the work done WAB. We find out the work done WAB is equal to VB minus VA. This is the potential difference. VB minus VA, because here VB is closer. VB and here it is VA. So difference of potential we can take and find out the work done per unit charge. So WAB upon Q naught. So this is the formula for potential difference, wherein we find out the work done to bring a charge from infinity to A. So it will be 1 upon 4 pi epsilon naught Q upon the distance here. So naturally here the potential difference, if I take as V plus dV, then if I am moving away from this, then it becomes V. So there is a difference of potential dV here. So potential difference, that can be written as dV. dV is the potential difference. Potential difference VB minus VA. You can find out from the formula WAB upon Q naught. So you have to remember this another formula for potential difference. Now potential difference has a unit. Unit is equal to work done per unit charge. So it is joule per coulomb. So amount, if 1 joule work is done to move a charge from infinity, 1 coulomb charge from infinity to the given point, then the amount of work done is called as 1 volt. So 1 joule upon 1 coulomb is equal to 1 volt. So unit of potential difference or both potential is volt. You can see that it is the work done. So potential as well as potential difference, both are the scalar quantities. They are scalar quantities. So we can directly add them without taking any directions. So this is the potential due to a given charge 1 by 4 pi epsilon naught Q by R, where Q is the source charge and R is the distance from the source charge. This is for a single charge. If we have, say, number of charges, then how to find the potential? So let us consider that case for more than 2 charges or say number of charges. So therefore the total potential due to this number of charges is V is equal to V1 plus V2 plus V3 plus V4. So therefore you have to just take 1 by 4 pi epsilon naught. It will be common for all this and you can take it as say Q1 by R1 plus Q2 by R2. Then third and fourth also in the same way. Q3 upon R3 plus Q4 upon R4. So in this way we can get the total potential by using the principle of superposition. We have to just add the charges. So it is a scalar addition. To find the total potential, we can just find the individual potentials and add them. So this is how we can add the electrostatic potential due to number of charges. Now next is the property called as equipotential surfaces. Let us see what are equipotential surfaces. From the name itself you can understand equi means same or equal and potential is the work done. So equipotential surfaces are the surfaces on which the potential is same. For example, for a plus Q charge, suppose we have only a plus Q charge, then we have seen the electric field around this is radially outward. I am drawing here the lines of forces, electric lines of forces which are radially outward. Our formula for potential is this, 1 by 4 pi epsilon naught Q by R. So this is the potential. You can see that it is inversely proportional to R and it has got a spherical symmetry. All the points at a distance R will have the same potential. So here I will have this type of surface where all the points on this surface will have the same potential. So this is one equipotential surface. Another surface also I can draw like this, which is having another radius, say R. So here say V1 and V2. These are the two surfaces. On this first surface, the potential is same everywhere. On the second surface also the potential is same. On these two surfaces, potentials may be different. So equipotential surface is the surface where everywhere the potential is remaining same. In the same way, for a uniform electric field also we can draw the equipotential surface. Equipotential surface for this will be like this. So on this surface, if the lines are going like this, if I take a perpendicular plane, then on that plane everywhere the potential will be same. So a perpendicular surface is the electric field, uniform electric field. On this also the potential will be same. So this is the equipotential surface with certain potential, say V1. This is equipotential surface. On this the potential will be same. This may be say 10 volts, this may be 20 volts. But everywhere on this surface the potential will be same. So in this way, for different types of surfaces, we can draw the equipotential surfaces. Now let us see some properties of equipotential surfaces. The first property is the work done over an equipotential surface is 0. Work done is W by Q naught is equal to say VA minus VB. What is VA and VB? VA minus VB is the potential difference. Potential difference for the surface say A and B. By the formula, it is equal to W by Q naught. If the potential is same, then we can write VA is equal to VB. So over an equipotential surface, we will get work done equal to 0. So this is the first property, that work done over an equipotential surface is 0. Why it is 0? Because the potential difference by this formula comes out to be 0. So work done is 0. So there is no work done to move any charge or test charge over an equipotential surface. The second property is about the electric field. Since we had found the formula with the help of work done, we had got the formula for work done W is equal to minus F dot dr, and we can write the same as F is equal to Q into E. So Q into E naught minus Q into E naught into dr. So this we had called as W. W upon say dW or say W after integration. So if I am writing W, then I will get W upon Q naught is equal to minus E dot dr. So here, which can be written as E dr cos theta. So this is W upon Q naught is potential difference or PD V. So if the angle, if there is no potential difference, then it is the VA minus VB will be equal to 0. So E dot dr cos theta is equal to 0. So in that case, cos theta is equal to 90 degree. Cos 90 is 0. So angle